Good evening. Welcome to the ICSE Class 10 Physics tutorial. Some important points on Class 10 Physics for the students appearing for the ICSE examination in the year 2020. Point number 1. Students should read the question carefully so as to answer what is asked. Point number 2. Reading time must be utilized to make oneself familiar with the given data. Point number 3. Avoid selective study of topics. Point number 4. Avoid changing the order of sequence of questions and numbering system, numbering pattern. What you do, just have a look. Sometimes you do question number 1A, then you do B, and then after that you go to question number 2A, and then 2B, and then again 1C, then again 1C, and then 4A, then 4B, then 7A. Again you are coming to question number 3C. So please avoid this. I am saying avoid this. I am not saying that the marks will be deducted, but I am saying you please avoid this. So avoid changing the order of sequence of questions and numbering pattern, numbering system. You change the numbering pattern, you change the numbering system, what is given in the question paper. In the question paper, the question is given like question number 1, and you are writing in Roman, question number 1. You are using for question number 2, Roman. And sometimes even you are writing your own question number. You are attempting question number 3 in the question paper, and you are writing on the answer sheet question number 4. This is your numbering. So please avoid that. So avoid changing the order of sequence of question number and the numbering pattern, numbering system. Point number 5. Handwriting should be neat and legible. This is important point. Handwriting should be neat and legible. You write in such a way that one should be able to read it, what you are writing. You are writing P and it looks like H. Just have a look. You are writing P and you have to write down P, and your P is looking like this, H. You are writing P, but the shape of the P is like this. If you are using V, so this is capital V, and this is capital V, and this is small v. There is no difference between capital V and small v what you are writing. The size of the letters you see, even the shape also you see. So it should be legible, and capital V should look like capital V, small v should look like small v. When you are writing units of a physical quantity, for example, you are writing the unit of specific heat capacity, or any unit. For example, one unit you are writing J kg minus 1 and k minus 1. So see, this is kg. Here k is small and here k is capital. But what you do, you write J kg minus 1 k minus 1. See the size of the letter of both the k's. If you are saying this is small, then this is also small, which is wrong. Here k should be capital, and if you are saying this k is capital, so here it is capital, then again it is wrong, because here k should be small. So be clear about it. Here in kg, k is small, and here in Kelvin, k is capital. So J kg minus 1, k minus 1. Point number 5 was handwriting should be neat and legible. Point number 7. Point number 6. Learn tables and squares up to 30. Point number 7. Write answers to the point. To the point answers. What is asked in the question, you focus on that. You write to the point. Sometimes you write 3 lines, 4 lines. You are writing half of the page. Sometimes even you are writing full page. 1 page you have written, but the key word or the key words or that 1 or 2 sentences missing, which are the answer for that particular question. And you have written 1 full page, half of the page, and you are happy that you have answered the question. So you will be getting marks. So please write to the point. For example, if the question is water is an effective coolant, and you have to give reason. Water is an effective coolant. So when you are writing down the answer of this question is water is an effective coolant, and I am saying that you write to the point. So water is an effective coolant. Water is an effective coolant. This is the question. Give reason, and you are answering. Water is an effective coolant because it absorbs a lot of heat energy from the machine, from the heated parts. I think you should mention that the specific heat capacity of water is very high. And if you could please write down that it is 4.2 J G minus 1 K minus 1. So I think these two, at least the specific heat capacity. So we are looking for if the child has written a specific heat capacity or not, or if the child has written about the specific heat capacity or not, that it is high or low, or what is the value of the specific heat capacity. All these important points are missing, and you are writing everything. So I think for this question, you should write down water is an effective coolant, reason, and you should write down at least the specific heat capacity of water is very high, at least this should be there. And if you could write down please that the value is 4.2 J G minus 1, 4.2 J G minus 1 and K minus 1. So then this becomes an absolutely correct reasoning. You are writing down the specific heat capacity of water is very high, and its value is 4.2 J G minus 1 K minus 1. And further, if you are writing that, that means for every 1 gram, for every 1 degree rise in temperature of 1 gram of water, for every 1 degree rise in temperature of 1 gram of water, 4.2 joule heat energy is required. And this amount of heat energy, which is big, not small, this amount of 4.2 joule heat energy for every 1 gram of water and for every 1 degree rise in temperature is taken from the heated part of the machine, heated part of the engine. And that is why, because see, 4.2 joule heat energy is taken, a big amount of heat energy is taken from the heated part of the machine. And how much is the rise in temperature of water? Only 1 degree for 1 gram of water. So that means it absorbs a lot of amount of heat energy from the heated part of the machine, and the comparative rise in temperature of water is very less as compared to other liquid. So that is why water is used as an effective coolant. So the 2 points which are important according to me is, first of all, you please write down that the specific heat capacity of water is very high, and if you remember, please write down the value also, which is 4.2 J G minus 1 K minus 1. Okay, now next point is point number 8. Express the answer only in SI unit unless otherwise asked. So this, I hope you know that every time you have to write down, you have to use the unit, SI unit you have to use. Always you have to use SI. First of all, you must write down unit. When you are writing down the answer, there should be unit. You should write down unit, and that unit also SI unit. Unless it is asked in the question that you have to express in gram or in centimeter, etc. If nothing is there in the question, you have to use SI unit. Point number 9. Write the given data first and convert in the same unit before substituting the formula. First of all, you write down the given information. Read the question for the numericals. You read the question and write down all the information given. For example, given D is equal to some 4, 1, 4, 5, something 1, 4, 5, 7 or something, right? This is meter, alright. And suppose this is meter, and suppose the speed is given. The speed is given, v is equal to given in kilometer per hour. In kilometer per hour. So one is given in meter, another is given in the value I don't know. Randomly I have taken the value. I just want to tell you that if distance is in meter and velocity is in kilometer per hour, alright. So one is in meter, one is in kilometer. Alright. Both should be in meter. Both should be in meter. Or suppose this is in centimeter. Suppose this is in centimeter. Suppose this is in centimeter and this is in kilometer per hour. Both should be in the same unit. This should also be in meter and this should also be in meter. So when you write down the complete information given in the question paper, you read the question paper and write down all the information, then you'll come to know, because everything is there in front of you now. So then you will see, okay, D is the distance is in centimeter, and speed is, the velocity is in kilometer per hour or meter per second. Meter per second, maybe meter per second. Maybe meter per second. Alright. So one is in meter per second, the other one is in centimeter. Both should be in the same unit. Alright, this is in CGS unit, this is in SI unit. Both should be in the same unit. So better you write down all the information given, and then you will easily come to know that if all the physical quantities are in the same unit or not. If they are not in the same unit, you should write down in the same unit. You should convert in the same unit before substituting in the correct formula. Point number 10. Learn the principles, laws and definitions accurately. As it is. Don't make any changes. Don't use your, you say that you have understood, and so you need not learn the definition. You will write down in your own words. It's okay, but sometimes what happens, you don't know which word is the key word. And if you miss any keyword and you don't get the complete sense of the definition, then you lose marks, then the definition will go wrong. So you learn the definitions, the principles and the laws as they are given, or as they are given by your teacher. If sometimes your teacher is saying that no, what is given in the textbook is not correct, I am giving you some a better definition, so it's okay, fine. But what is given, the actual law, the actual principle, you please, or the definition, you please write as it is given. Alright, for example, if you are writing, suppose the Ohm's law, the statement, the law says that the current flowing through a conductor, the current I flowing through a conductor is directly proportional to the potential difference applied across the ends of the conductor. Right, and you are writing this much only. The current flowing through a conductor, the current flowing through a conductor is directly proportional to the potential difference applied across the ends of the conductor. Alright, you are writing this much. But see the later part, there is one more line, one or two more lines. What is that? Provided that the physical conditions and the temperature of the conductor remain constant. So if you're not writing the second part, the later part, then the Ohm's law will be wrong. So you write down complete definition, accurate definition. So the complete statement of Ohm's law will be: the current flowing through a conductor is directly proportional to the potential difference applied across the ends of the conductor, provided that the physical conditions and the temperature of the conductor remain constant. If you are missing temperature, or if you are missing the physical conditions, then it will go wrong. So please learn the principles, laws and definitions accurately. Point number 11. Focus more on conceptual learning rather than rote learning. Point number 12. State the meaning of the symbols if the answer is given in terms of any formula or mathematical equation. For example, you are answering one question by writing down this formula, MA is equal to L upon E. So please write down, what does MA stand for? What does L stand for? What's the meaning of E? So write down where. So you should write down where MA is equal to mechanical advantage, L is equal to load, E is equal to effort. Alright? Or if you are using some other formula like V is equal to F lambda, if you are using V is equal to F lambda or N lambda, V is equal to N lambda. So write down the meaning of V, that of F and that of lambda. So V is equal to speed, full you will write down speed of, F or N the frequency, and lambda the wavelength. So state the meaning of the symbols if the answer is given in terms of any formula or mathematical equation. You write down the meaning of the symbols used. Point number 13. Use abbreviations or symbols which are standard, acceptable. You don't make your own abbreviations and the symbols. For example, students write small f to represent focus. I am talking about focus, not focal length. Focus, focal point. And they say, sir, F to hai na. Please try to understand. Capital F, which represents the focus of a lens, is a point. Capital F is focus. Capital F is focus, focal point. Whereas small f is focal length. For example, if you are taking a lens, this is your optical center f1, f1, 2f1, f2, 2f2. Alright. So focus and focal length. This is focus, second focus, we call focus. When we say focus, see, please listen to me carefully. When we say focus, that means we are talking about second focus, f2. Alright, so focus means second focus, focal point. So F is the focus, focal point, F. Alright, F2. And from O to F, this distance, this is small f. focal length. So in place of small f, you cannot use capital F. In place of capital F, you cannot use small f. One is a point and one is distance. I hope you understood. Point number 14. Solve at least the last 4 or 5 years ICSE question paper. Point number 15. Express final answer with proper unit as per the requirement of the question. As per the requirement of the question, you write down the final answer. Point number 16. The speed of light for all wavelengths is in vacuum is same. The speed of light for all wavelengths in vacuum is the same. Point number 17. Another important point. Please look at it. Listen to me carefully. Point number 17. Another important point where I am saying that do not write down shortcut answers. So no shortcut answers. No shortcut answers. Point number 17. Point number 17. No shortcut answers. No shortcut answers. No shortcut answers. What does it mean? Please see example. You have to write down complete answer. I am saying do not write down shortcut answers, incomplete answers. What does it mean? Please have a look. Listen. Suppose you are writing down the factors affecting the resistance of a conductor R, and you are writing these are the factors. First factor you are writing L, length. Alright, so the length, so you are writing only length. You are writing length. Second, you are writing area. Third, you are writing temperature. Alright, third you are writing temperature. Second, you are writing something else. Third, you are writing temperature. What I want to tell you is you write down length of the conductor. Of the conductor is important. Temperature of is important. Temperature of the conductor is important. This of the is important. So do not write down incomplete answer. Shortcut answer. Write full. Temperature of the conductor. Length of the conductor. Alright. In some other context, refractive index. If suppose you are answering some other question where one of the factors is refractive index. So if you write refractive index, so you are writing refractive index. Refractive index. Alright. Write full refractive index of the what? Material of the prism. That also not prism. Please listen. Refractive index of the prism? No. Refractive index of the material of the prism, of the glass. Complete answer. Give complete answer. No, I think this is a very important point. First of all, you should not write down refractive index. Secondly, you should not write down refractive index of the prism. Refractive index of the material of the prism. Refractive index of glass. Point number 18. Practice to draw diagrams. Practice is very important. Practice is very, very important. So do practice. Do lots of practice. Alright. Now point number 19. When choice-based questions are asked, then yes or no should be answered. Yes or no should be answered. First you write down yes and then give reason. Or first you write down no, then you give the explanation. Alright.
indirect answers may not be accepted. So first you write down yes and then you justify it, or you write down no and then you justify it. Then point number 20. Important keywords of the definitions should be stressed upon. This has been discussed in point number 10. I've just discussed in point number 10. I covered up this point. Point number 21. Students are another important point, very, very important point, children. Please listen carefully. Students are under the impression that the work done is zero during the motion of a body on a circular track. Motion of a body on a circular track, because the displacement is zero. This is a circular track. A circular track. A body is moving on the circular track. Alright, this is center. Alright, body is somewhere here. Body is somewhere here. Alright. So some students are under the impression that the work done is zero during the motion of a body on a circular track due to zero displacement. Displacement is zero. Displacement is zero. Alright. This concept needs to be rectified. It is because here theta is 90 degree. Theta is 90 degree. And cos 90 is 0. So when you write down W is equal to F S cos theta, so you write down F into S into cos 90. And the value of cos 90 is 0. Alright, so you write down F into S into 0. Alright. And because of this 0, everything is 0. So it is because of theta is equal to 90 degree, the work done is 0. Got it? Alright. So this was another important point. So now point number 22. The principle of ideal machine is sometimes confused. The principle of ideal machine is sometimes confused with the principle of movement. So be clear about what you know, what is correct. Be clear about it. There shouldn't be any confusion. Point number 23. Discuss more examples of energy conversions. More examples. As many examples as you can. Some examples you got from the textbook. Some examples you got from your school by your subject teacher. Some examples you are getting from your maybe parents, your elder brother, your sister, one who is doing engineering, or your brother, one who is doing engineering, your tuition teacher. From wherever you are getting all these informations, you make a chart, you make a table every day, or whenever you get one additional information, extra conversion, energy conversion, please write down. So already you have 12, 13, 14. Then 2 you are getting from one person, 1 you are getting from your brother, 1 you are getting from your tuition teacher. So all those things you collect at one place. And now you have 25, 30 energy conversions. Alright. So please do that. Discuss more examples of energy conversion. 24, point number 24. While writing points of difference between two physical quantities, give important points. Sometimes, suppose you are writing down the difference between any two physical quantities. Say for example, work and power. Alright, work and power, you are writing down the difference between these two physical quantities, and difference between work and power. So you are writing work and you are writing here power. Power, right? What I think, so generally what I have seen, generally what is observed, what is seen, you are not writing down the important points, and you are writing down the less important points. The important points are like what I think. First, the definition. The definition of both the physical quantities. Write down first point of difference as what is the definition of work done, that you write down here. What is the definition of power, that you write down here. Very strong point. Second point, you can write down unit. For example, the unit of work done is joule. If you are writing only J, capital. If you are writing full, then Joule, joule. The unit of power is watt. Or see the difference between W and W. Alright. So one point is the definition, and second point is the unit. These are the two important points, and mostly they ask you to write down only 2 points. So they are the 2 important points. So write important points. What some students do, generally they write down less important points. Point number 25. The color of light and wavelength are same points. They cannot be taken as 2 separate points. Similarly, refractive index, nature of the medium, and optical density, they are same point. Now you think you have written 2 points, 2 or 3 points. The question was for 2 marks. Write down 2 points, and you have written 2 points. One, refractive index of course, complete refractive index of, and the nature of the medium, and you are very happy that you have written 2 points. But they are not 2 different points. They will not be taken as 2 separate points. They will be considered as 1 point. So that you should be very, very clear. Alright. So that means you have given only 1 point. Though you have written 2 points, you are thinking that you have given 2 points and you will get full marks, 2 marks for this question. But the 2 points that you think is 1 point, so you will get 1 mark. Point number 26. Ambiguous points need to be avoided. For example, nuclear energy was given as a clean source of energy, whereas it is still a debatable point. It is not a clear source, it's not a clean source of energy, because very harmful nuclear radiations are produced in the process, which are highly penetrating. Or the nuclear waste causes environmental pollution. So no ambiguous points. You should avoid writing down ambiguous points. Next point, point number 27. Sometimes a word conveys the meaning partially but grammatically incorrect. For example, higher the length is used in certain answers. Point number 28. The accuracy of answers is important. Accuracy of answers is important. Point number 28. Another important point. So many important points I have given you. I am giving you which are very, very important for you ICSE examination 2020. Why ICSE examination? Even for your preliminary examination. Wherever you are writing, whichever exam you are writing, all these points are very important. Alright, so even in your prelim examination that you are going to write in the month of January, please follow this, what I am saying. Alright, so next point is the accuracy of answers is important, and for this you should know rounding of the digits. You should know the rounding of the digits. How to round off a digit. I mean 5. If it is 5 or more than 5, then the previous digit is increased by 1, and if it is less than 5, then we keep as it is. Alright, so I hope that you know. The second point is rules to write significant figures. All those rules you should know. The significant figures. This is little difficult. Difficult in the sense you need to know all those rules. And this will help you when in mathematics also, when you are doing especially the quadratic equation question where you are asked to find out to solve a quadratic equation and write down the answer up to 2 significant figures or up to 3 significant figures. Alright, so there also this knowledge will help you. So significant, knowing the rules of significant figures and practicing of rounding of the digits, they are very, very important. So please do that. I will be explaining the rules for writing down the significant figures and how to round off a digit, but that in my next lecture. Next point number 29. It is advisable to stick to simple examples rather than uncommon examples. Give simple examples which you see in your day-to-day life, which are there in the book. Sometimes you are giving some example which are really uncommon and maybe debatable also at the same time. Alright, so give simple examples. Point number 30. Interrelation between speed, wavelength, frequency, color, refractive index should be clear. You should know the relation. Point number 31. In numerical problems, please write down according to the principle of moments or according to the principle of, please write down this. What? When you are doing numerical, please write down according to the principle of moments or according to the principle of calorimetry. This please write down. This is important. As the case may be, if you are doing question on calorimetry, then please write down according to the principle of calorimetry. If you are doing a question based on moment of a force, then please write down according to the principle of moments. Alright? Point number 32. Answer should be in decimal with correct unit. We have discussed this. No answer should be left in fractional form. Please understand. No answer should be left in fractional form. Even in mathematics also. Alright. So especially when you do linear integration question, so 3/2 should be written as 1.5 or 1/2. But better you write down 1/2 is also correct. But it should not be like 3/2, improper fraction. And here in physics, it should be in decimal, not even in mixed fraction. So 3/2 should not be written down 1/2 in physics. You should write down 1.5. So answers in decimal with correct unit. And of course, when you are writing down the answer in terms of decimal, in decimal form, then you should know, you should have the knowledge of rounding of the digits and the significant figures if the question demands that. Point number 33. In machines, the tensions in the upward direction in different strands, load L vertically downwards. There must be a fixed support, which is important. There must be a fixed support, and there should be a fixed support like this. Alright, and then you do whatever you are doing. Then you do, alright. There must be a fixed support, and then tensions in different stands, and then the tension should be in the upward direction, and there should not be a fixed support is important, and there should not be any slack. The string that you are using, alright, so it should go like this. It should not go like this. No, not like this. No, not like this. It should go straight. It should go straight like this. Straight. Alright? Straight. Like this. Alright? Straight like this. Alright? So I'm not completing the diagram because here I am telling you about this slide. This should not be. Alright. Point number 34. It is better to inculcate the habit of underlining the important points or the keywords in the answer. If there is any keyword in the answer, if there is any important point in the answer which you think this is the keyword, this is very important, this and you just want that the examiner should say it because according to you this is important. Alright, so then that you may underline. Alright, now in the end, specific points, do's and don'ts on a particular chapter separately in my next lecture. Thank you so much. Thanks a lot.
I'm in love with the cold, cold